Video problem 48. This one is on percent yield. So first of all, it's a percent, so it's always a part over the whole. And what we're doing here is we're taking how much of a certain substance we actually form versus how much we should form, which is the theoretical amount. And then it's a percent, so it's times 100. So the actual is, we do the lab and we measure, we weigh out the actual amount that we form. The theoretical is usually the calculated value, and in this case, it's how much we should get through stoichiometry. Okay? So let's see what we have here. A sample of 15.6 grams of benzene is reacted with excess nitric acid. In the reaction, 18.2 grams of C6H5NO2 is recovered. Determine the percent yield of C6H5NO2 in this experiment. So in this reaction, 18.2 grams of this is recovered. That's the amount that we actually have. So in other words, we perform this lab, and at the very end, we get 18.2 grams of C6H5NO2. That's how much I actually form. What I want to know is how much should I form? Okay? So we start out with 15.6 grams of C6H6, line with a G, line with a moles. I'm looking for how many grams of this substance, line with a G, line with a moles. So grams to moles, moles to moles, moles to grams. Okay, so it's nothing new here. It's just we're using it in a different way. So let's see, I've got 15.6 grams of C6H6, right? 1 mole on top, grams on bottom. That's molar mass, so it's molar mass of benzene, which is C6H6. So I got 6 times carbon, which is going to be, what, 72.06. And then I've got 6 times hydrogen, which is 1.048. Let's see, make sure I'm right here. Big silly head. This should be 6.048. You guys knew that though, didn't you? So let's try, there we go, 6.048. Alright, so that I end up with 78.108. Had a hard time saying 78 there. That's how many grams per mole. So that's 78.108. Alright, and then I'm going to go ahead and convert that to moles of C6H5NO2. And it's a 1-to-1 reaction, but I'm still going to go ahead and show that calculation. Right. And then I'm going to go ahead and convert to grams. So C6H6 cancels out, grams cancels out. Got moles. I'm going to put grams on top, moles on bottom, and that's the molar mass of C6H5NO2. Right. So it's 6 times carbon. That's 5 times hydrogen. That's 1 nitrogen. And that's 2 times oxygen. So that's 32. That 1 nitrogen is 14.01. The 5 times hydrogen, 5 times 1.008 is 5.04. And then the 6 times 12.01 is 72.06. So let's add all those together. And I get a value of 123.11, that's grams per mole. Okay. So then let's carry out the calculations. It's 15.6 divided by 78.108 times 1 divided by 1 times 123.11. And I get a value of 24.6, I'll say. And that's grams of that big compound C6H5NO2. Right? So let's do our percent yield. It's how much we actually got, which is 18.2 grams, divided by how much I should get. So I should get 24.6 grams. So I have less than 100% yield, which is normal, times 100. So I'm going to take 18.2 divided by my 24 point number times 100. So I get a value of 74. If I go to 3 sig fig, 74.0% yield. Okay, so I got 74% of what I should have gotten. That's percent yield.